Um, okay, so thank you all for joining again. And Women in AI, as you may know, is a community-driven initiative. And basically what we do is try to bring empowerment to our community via like different education programs or like research or events and blogging. So today we have this WaiTUTORIAL talk, which is basically one of our programs, which is that is part of the education like a segment of Women in AI, right? And basically what this WaiTUTORIAls aim to do is have like at least 15 minutes presentations on like topics that would be beneficial to our audience or anyone who is like maybe a beginner or basically ranging from beginners to advanced levels there, right? And you can, I would say the goal is basically to see that within those 30 minutes or 15 minutes, you can at least get a decent perspective on a topic that maybe a buzz topic or something new for you. So I would say just something to mention there is as part of the the Women in AI program or the education segment, we have the WaiTUTORIALs and we have Practice, right? I would say more as opposed to the 30 minutes section, it's more of a 4-week driven program, and we would have one of the sessions coming up in August, so you should keep your eyes out for that there. And there would also be a follow-up WaiTUTORIALs later on in July, so also keep your eyes peeled for that. So okay, so I'll go on and present Abhishek here, right? So Abhishek, thanks for joining. So Abhishek Mandal is currently a research student, right? Fondly you're working for your research is with the SFI, that's the Science Foundation for Ireland, I think, for the Research Center for Data Analytics, is it? And then currently your research focuses on auditing biases and imbalance for deep neural networks, right? I think, and computer vision there, right? And in this session, you basically be diving into like generative images from text and so the basics of diffusion models, how they get trained, how to use them effectively, and any challenges with regards to like bias or ethics that surround them. So yeah, I hope I tried to capture that perfectly. So I'll give it over to Abhishek now so you can give out the details there. Thank you.
Thank you, Luciana. Thank you for the introduction. So hello, everyone. I'll just share my screen. Yeah.
Thanks.
So my name is Abhishek Mandal, and I'm a doctoral researcher in deep learning. And my specialization in is computer vision. I'm a student at the Insight SFI Center for Data Analytics at Dublin City University and University College Dublin. So today's session would be on generative AI. It's a very popular buzzword right now. In the past few years, this field has seen tremendous growth, and as per some experts, this is the field that is going to have the most profound impact on our society when it comes to artificial intelligence. So I think that many of you may have heard of the term stable diffusion, mid-journey, or DALI, or at the very least, you would have heard of ChatGPT, a very, very popular model from OpenAI. It has been in the news. So similar to ChatGPT, so ChatGPT generally works on the text domain. So it generates text based on input from humans. So similar to ChatGPT, there are some models which generate images or even videos from human input. The human input is generally text. So this is going to be a no-code session. And it's a very beginner level session, so no prior knowledge of coding or generative AI is required. We'll see some prompt engineering, which is basically done in English language. It's going to be around 25 to 30 minutes, and then we'll have around another 10 minutes or so for follow-up questions. So let's begin. So you may have or may not have seen these images. The one on left shows the Pope wearing a highly stylish jacket. And initially, when this image was reported in the media, many people actually took it as real, and a few people started commenting on social media that the Pope is very stylish, his fashion sense is very good. But later on, we found out that it's not a real image. This is not the real Pope. Well, I mean, in the image, it looks like him. But this image is not real. It was generated using a text to image diffusion model. It was called Midjourney. And it uses, earlier it used another model called stable diffusion, but now I think they have created their own version of backend model. The image on the right side, you see, it was also generated using diffusion models, again, Midjourney. This shows billionaires as if they were poor. So it recreates famous billionaires like Elon Musk, Bill Gates, and Jeff Bezos as slum dwellers. So as you can see, these images, they look very real, and this can be used to even fool people if they are not knowledgeable enough about this field of artificial intelligence, which sadly is, I think, most of the general public. What you can see here is that not only these models can generate highly realistic images, but it can generate images that do not basically exist in the real world. I cannot imagine, Bill Gates or Elon Musk looking like this. Or, even if there was some possibility they look like this, they would make sure they are not photographed in this situation. So what these models are doing is that they are creating highly realistic images, but those images are fake, like they do not exist. So they are basically combining different concepts and merging them together. So the model actually knows what Bill Gates looks like and what a slum dweller looks like. So it's basically the model is able to merge these two concepts and create something highly realistic. So these categories of models are called diffusion models, and we have some very famous examples such as DALI, released by OpenAI, then Stable Diffusion by Stability Incorporation, and Midjourney. And this one is a screenshot of from DALI's official website. And as you can see, this is the text here. And upon inputting the text to the model returns an image. So the images are highly improbable. These things do not exist in the real world. And basically, these kind of things would be imagined either by children or artists. Like normally, people don't imagine a mad panda scientist mixing chemicals or a Shiba Inu wearing a turtleneck. So these kind of images show us the imaginative and the creative capabilities of these models, and these models have started to have profound impact on our society, which ranges from, decreasing the number of available jobs for many artists and graphics designer, to the potential of creating fake images and spread disinformation. So how do these models work? So although these three are different models, they belong to a family of models called diffusion models. And they generally, so this is a very high level overview. There are certain differences in the internal working, and like models like DALI and Midjourney, they have not released their architecture, the latest architecture, in public domain. So we have only have a very high level idea of how they would work, but this is a very good high level idea of how they work. So they generally consist of two parts. The first part is called CLIP, which stands for contrastive language image pre-training. So this is a separate model. The job of this model is to convert the text that is inputted by the human user into some sort of internal embedding. So these internal embeddings are nothing but mathematical representations of the input text. And then there is the diffusion phase, the diffusion model, which converts those embeddings into the final image. So the first part, CLIP, the way it's trained is that it connects images and text. So that model is open source and was created by OpenAI, also the creators of DALI and ChatGPT. So that model was trained on 300 million image text pairs crawled from the internet. And so basically the model was shown an image with a text description. So for example, this is an image of a dog, and the text is Pepper the Aussie pup. Now, when the model is shown millions and millions of such image text pairs, the model starts to find out patterns. For example, if this is a dog-like creature, like a small with a flappy ears and a big snout, and if it sees the word dog in all the text description, then it starts creating internal patterns that connect these visual features with the word pup or dog. And when it's shown enough images and their textual description, it starts to have a very good idea of different concepts from the real world. The second part is the diffusion model. So how they're trained is first an image is inputted, and then a noise is gradually added to the model to that extent that it becomes virtually like unrecognizable to normal human beings. And then there is so that is the encoder part, and then we have a decoder part, which sort of tries to recreate the original image from these noisy embeddings. So what happens in these diffusion models is that we cut it in half and take the embedding, the decoder part, which generates image from these embeddings or the noisy data. And when we feed it, if we go back, so this is the clip part where it creates these sort of embeddings, and then which are called priors, and these noisy embeddings, these are then fed into the decoder part, which then finally creates the image. So the prompt that is used for generating these images, sorry, the text that is used for creating these images, they are called prompts. And you might have heard of this term called prompt engineering, which is supposedly the new best job in the world. So the aim is to give the model enough information so that it can generate the desired output. So we shall see how this thing works. So this is an example of a prompt. So the prompt that was given to the model, by the way, this is generated by DALL-E 2. So the prompt is an apple on a sidewalk of Hong Kong, EOS 70, 24 mm, f/8 bokeh effect. So as you can see, this image looks like as if there was an apple which was kept on the sidewalk, and then somebody took an image with the bokeh effect. Now, if we look into the anatomy of the prompt, so first we need a subject. So here the apple, which is the subject. Then the apple needs to be placed somewhere. It can't just hang around in free space. So that is the placement on a sidewalk of Hong Kong, which is the context. So it might be, a sidewalk of Hong Kong. So you can see these, tall futuristic buildings reminiscent of Hong Kong, but it might be, we can say, the sidewalk of Dublin. So, this gives the model some context about how the surrounding or the background should look like. Now, EOS 70 is a camera by Canon. So this model knows what how images taken by a Canon EOS 70 looks like. So it will try to recreate the image in a way that makes it look like that it was taken from a Canon EOS 7D. Now 24 mm is the film type. Now you might say that this is a digital camera. So where does the film type come? So we'll discuss that later. f/8 is the aperture length, and bokeh effect is the kind of effect that blurs the background and focuses on the subject. Now, this is an example of realistic photography. But the thing is that if you look closely here, I've mentioned EOS 7D, which is a digital camera, and 24 mm. So 24 mm is the film size. So in reality, you actually cannot take this photograph with a EOS 7D. So these models can actually create images which are not even possible in the real world. So even though we call it realistic photography, we can tweak the effects in such a way that can generally only be generated after significant post-processing using softwares such as Adobe Photoshop. Now, if we tweak the prompt a little bit, so earlier we used the bokeh effect, but if we change it from bokeh to fishbowl effect, so it created the image as if it was taken using a fishbowl lens. So by tweaking these different parameters, we can create images as per our liking. And this is what prompt engineering is all about. Now, what if we change the other parameters? So earlier, we used sidewalk of Hong Kong as the placement, sorry, the sidewalk as placement and Hong Kong as context. But what if we change it to and see what it's like for indoor photography? So we changed it from sidewalk of Hong Kong to an apple on a chair. And then we added some other information, which is studio lighting. So if we were to place an apple on a chair and then in a studio, and then use the studio's, the different lighting options and take an image, take a picture using Canon EOS 7D, then it would look like this. So by tweaking these various parameters, such as the camera, the type, the placement, the extra settings and style, we can create very realistic photography that would actually be taken by professionals. Now, that was realistic photography. What about art? Now, this prompt here, now the structure of the prompt remains same. So this is the subject for this image is children playing in spring. That is the context in a village near the Swiss Alps. Impressionist art, Claude Monet, high quality. So the model knows what Impressionist art is, what a village near the Swiss Alps look like, and basically what spring is, and then try to recreate it in a style that the famous artist Claude Monet would paint if we were to give him these instructions. Then the second, this image shows anime children playing in autumn in a city park in Tokyo. Sharp, detailed anime style cinematic lighting. So using different types of prompts, by changing the parameters, we can literally generate any type of image, whether it's realistic photography, whether it's art, whether it's comic books, whether it's anime, anything. You don't need an expensive camera, an experienced photographer, an experienced post-processing graphics editor. You just need this model, and you should have some subject knowledge about this, and you can generate anything with just a few clicks. Now, we have seen the potential of generative AI, but is everything okay? Let us see. So I gave this prompt to DALL-E, a photorealistic image of a data scientist working hard. Let's see what it generated. So you see two men working hard. This looks like a laptop computer. This is also a computer. And yeah, so both sort of middle-aged men, mostly from Western countries. And this is another image again, a man in his, I think, late 30s, working on his computer, and again from the Western world. Then I gave it a prompt, an image of a parent cooking dinner for kids. Let's see. Here, although this is the first iteration of DALL-E, so the images were not that great, but we can see what it imagined. Sorry, if we're to say in common language, when I asked it to imagine a parent cooking dinner for kids, we can see these generated images. Typically, the subjects look like women. And same here, the subject, they definitely has female visual characteristics. And an image of a parent teaching a child baseball. And see, the parent looks like a man. And same here. Then an image of a flight attendant smiling. Let's see, it's an image of a woman. This is my favorite. I asked it to generate an image of a feminist. Let's see, it's a woman shouting on a microphone. And again, the same here. So we see that even though these generative models have a lot of potential to impact our society, improve our performance, and take away many jobs possibly. But these models also suffer from hidden internal biases. So as you saw, that it imagined data scientist as a man, and a flight attendant as a woman, as well as it thinks that cooking dinner for children is a woman's job, and teaching baseball to kids is a man's job. So there are, although these models are being deployed commercially in many applications across the world, some of which are very popular, these issues still remain, which needs to be audited and checked, or else there is a potential for a lot of harm if we just deploy these models without proper auditing and checking. And this concludes this talk. And any questions?
Thanks, Abhishek. That was really good and well detailed, I would say. Love the fact that you mentioned sort of the bias part, because I think someone put that comment in the chat there so as well. So we have one question there, and I would just maybe quickly try to summarize it. So you spoke about the prompts, right? And how it is that we would need to enter the prompts and that generates the image, right? And so the engineering of that prompt. So someone is asking, right? If a user, or as a user, if I go in, put my prompts in and I get an image from that, or even a video, right? Who would own who would own the copyright of that? Is it me, the user, because I prompted that image, or is it going to be the machine itself because it was able to sort of give you that image based on your prompt? And yeah, I think, yeah, that's the question we have from Alja. I hope I'm not pronouncing your name wrong. Sorry, Omar, I think I just got your surname. So yeah, so we have that question.
Yes, Omar. And the question is two-part. First part is, can you hear me?
Yeah, we can.
Yeah, the first part, as I mentioned, is basically if I do the prompting itself, do I own the IP itself or the copyright? I can use it commercially, or it will be the company, like in this case, Midjourney or any of these other companies. This is this one question. Second question. So now sometimes I can start with the foundation. I can bring a picture. It can be personal picture, or I can bring a picture from anything from the internet. So it is, this one picture have a copyright. If I use it as a foundation and then the AI generate another image on top of that one, how this is solved? I think this is an issue that this is going to be a really big problem. And the second thing now, even prompting now, even the new versions of text to image, it became even I can create videos now. So you're going to have more and more full video clips. Even games are using this kind of technologies. This is going to start a nightmare for copyrights from games, from videos, from images. How I can protect myself?
Okay, thank you for your question, Omar. So the first part of your question is, well, it depends from company to company. So DALL-E and Midjourney now are fully paid versions. So whatever you generate, the copyright rests with the creator. They have specifically mentioned it. There are other free open source versions as well, and which they have not like made it clear, but the big companies have made it clear. So once you generate an image, it's yours. The second question is that as of now, we do not know, because there are certain court cases going on as of now in the United States, where many original artists and authors have sued these large companies like OpenAI for ingesting, sort of like taking their work to train these models. So this court case is still going on. So we don't know what kind of a verdict we are going to get. But once these things, this court cases get resolved, then we can get some idea. I think maybe the big companies will compensate the big authors, but the like normal people, I'm not sure how they're going to deal with that.
Thanks, Abhishek. Okay, so we have another comment there, or even a question there. So they're asking, is it possible for you to explain or give some more details on the matrix that you had shown on the third slide?
Okay. This one?
I think that would be the fourth one, I think. I don't see a matrix here unless
I mean, like, if this, sorry, I didn't, I forgot to put numbers.
Atefa was a Hosseini, I'm not sure. Is that, what slide are you referring to? Maybe you can just scroll, Abhishek, and maybe stop on where you
Yeah.
have a matrix.
Is
as
this
well.
the one?
I think there was another one.
This one?
Yeah, I think.
Oh,
this.
okay. So yeah, I didn't explain this because it's a bit complicated. So the clip model actually has two different kinds of encoders. One is an image encoder and another one is the text encoder. And this creates, these two encoders create embeddings or mathematical representations of the image and the text. Then the model is trained where it calculates the cosine similarity between the text and the image. And so there is this process called contrastive learning, where it tries to calculate the similarity between all the possible images and text, and whichever pair has the highest similarity, that is what the model learned. So this is a bit technical part, so as to keep it non-technical. I think this is the simplest explanation. So these are the similarities between the image text pairs. So if you look at it closely, the first image shows this image of a pup, but there are different images behind it, and so different textual description as well behind this. So all these comparison is done, and then this is how the model learns.
Thanks, Abhishek. Hussein, I hope that answers your question.
Mm-hmm. Yeah, so.
Okay.
Yeah, okay. Thank you, Nabnita, for your question. So yeah, the EU AI Act actually categorizes uses of AI in different categories, from low risk, such as gaming, to high risk, such as social profiling, or place where AI is used with children and vulnerable people. So yeah, they so outright the EU AI Act does not ban these kind of models, but it limits to in which sectors and applications these models can be used.
And I don't know if that ties into the next comment there. Someone says, in terms of AI bias, do you think that over time AI can learn from human correction to minimize or correct the bias, for instance? Okay, to correct the bias, right? And then they say, for instance, when I use ChatGPT, I prompt it through several iterations and it edits its response until I am happy with it.
Okay. Yeah, thank you for the question, Luciana. So yes, there is this element of human correction. For example, the images where I generated an image of a data scientist working hard. So there I didn't mention the gender. Now, if I had used certain prompt like images of a woman data scientist working hard, or image of a father cooking dinner for children, then it would be like that's one way to debias it. So you have to like prompt it there. But the thing is that these models are not meant to be used in this way. For example, I may have heard of generative fill in Adobe Photoshop. So there as well as there are these models are integrated with other applications, for example, social media applications, then education based application, where this direct feedback from the user is not possible. So there, this correcting facility is not easily available, and there the bias can manifest externally in the final output.
Thanks, Abhishek, for that. Okay, let me see here. Okay, so Omar again says, is there any open source text to image LLM LLM that we can fine tune for our specific requirements, and how do we do it, and how to do it, or how do we get it done? So yeah.
Okay, so thanks, Omar, for the question. The thing is that this is not an LLM. So LLM are large language models which only work on text. These are multimodal models which work on multiple domains, such as text and image, or say text and video. So yes, there are open source implementation. So Stable Diffusion itself is open source. We can so for example, I have that in my workstation, which I use it for generating. Now for fine tuning, of course, you can fine tune it. The code is open source, but for that you'll require very huge computing power. So yes, there is a Stable Diffusion itself, and there are other open source, smaller open source, such as DALL-E Mini by Hugging Face, Crayon, and like there are many such models right now. Like, you know, every month 2 or 3 new models are coming out. So yes, you can use them and fine tune them as per your requirements.
Great. Thanks, Abhishek. Amara, I hope that answers your question. Okay, so we have another question here, and this one is interesting for me as well. So Mary says, when you talk about these embeddings, they come with weights and assumptions already attached. Isn't it the cost of the hallucinations of the models? How are researchers able to minimize the hallucinations and maximize for accuracy?
Okay, so okay, there is another question before that, but I'll take it later.
Oh, is it? Okay. I must have
okay.
missed that one.
Okay, so for this question, well, now these models, like I showed you in the diagram, these are like multi-stage, multimodal models. So there are different individual models, such as there is clip and unclip. Then even inside clip, there is the text encoder, which is generally GPT-3 or something similar. So OpenAI hasn't told us what they're using. For the image encoders, we have CNNs, pre-trained convolutional neural networks, such as ResNets and vision transformers. So these are like a combination of many different types of models. So yes, there are many of the embeddings, the weights that the pre-trained weights are pre-trained. The thing is that many these individual models are trained on something else, pre-trained on something else, then they are attached, then they are trained, retrained, fine-tuned, then some other model is attached, then the entire thing is again retrained and fine-tuned. Finally, they are deployed for something called reinforcement learning from human feedback. So this thing is a highly complicated, complex, and multi-stage process. So yes, the weights that come from the pre-training, they do have like some influence, but these weights do get changed as the model becomes more complex and the training becomes more complex as well. Now, for hallucinations, well, this is generally more likely to be like a thing associated with chatbots and like ChatGPT, where you sort of these models can create something outright fake information. But these models are generally like single input, and whatever they are creating is generally fake. So so hallucination is not an issue that is generally associated with these diffusion models or text to image models. That is mostly associated with other chatbots like ChatGPT. Okay. The other question about GAN. So yes, GANs are also similar models, but these are not GANs. GANs work on a different methodology, a different technology. GANs can be used, can be misused as well. Maybe you have heard of deep fakes, but they cannot sort of imagine these crazy things like a mad panda scientist or something. They are very specific. If you ask it to generate an image of a face, it's going to generate an image of a face only. It won't generate something else. So that's a separate category of generative AI. But yes, they do, if they are misused, they do have the potential to cause serious harm. And we have seen them being used for creating serious harm before.
Thanks, Abhishek. Okay, we'll just maybe give some more time, maybe 5 minutes there for questions, right? So another still Miri. And so Miri is saying, how are researchers also working on tracing original sources of images for copyright / plagiarism? So I think is that maybe in regards to like training data or so? Maybe do you mean, or just in general, the output?
Yeah, that's a very good question. Yes, so so there are two questions. So the first question is like, yes, tracing images for copyright or plagiarism. The thing is that the data set that is used for training these models, especially by commercial companies, they are not made public. So we do not know what data they used. There has been some effort into recreating an open source version. One of them is called Lion, LAION project. It is similar to the Common Crawl project, which tried to sort of recreate the training data set for GPT-3 at that time, and Lion is an attempt to recreate the training data set used for training these image text models. So yes, there exist research and efforts to sort of create open sourcing the training data set, but this is not foolproof. One way of telling if they have been trained on copyrighted data is like one prompt that I showed you is like, create an image in the style of Claude Monet. So if it is very similar to the style, so it must have been trained on art created by Claude Monet. So if there is, there has been certain instances where there was this famous anime artist, and I think Stable Diffusion or Midjourney, I don't remember exactly, it was able to recreate anime in the style of that artist. So that's one way to sort of guess whether that was that particular artist's copyrighted data was used for training or not. But the way these massive data sets, for example, clip, that particular part was trained on 300 million image text pairs. After that, like the papers that were released by OpenAI, they did not mention how many images, or like how many data points were used for training these models. But we can, looking at the parameter count, we can say that it would easily be in tens of billions of say image text pair, and it's not possible for even the best engineer scientists to sort of check that much amount of data, create something to check if it's copyrighted or not. So the basic idea, the methodology that is used is that they use these search engines such as Google and Bing, and just crawl through all the data. So they just download as much data as possible with the image and the text, and then you feed it to their models. So yeah, accurately pinpointing would be difficult as long as we do not have access to the exact data set that was used for training.
Thanks, Abhishek. And team would have a hard stop there because we have 1 more minute, right, with regards to like questions. So what I would do is I just pasted Abhishek LinkedIn in the chat there, right? So you can go on and connect with Abhishek on LinkedIn and sort of post your questions there. And also, sorry, that's my timer there, so reminding me of the hard stop. Yeah. So so you can go on and connect with Abhishek on LinkedIn there. I'm sure Abhishek will be fine with answering those questions as well. But great questions. I honestly myself learned, I think it's the first time I'm learning about hallucinations with regards to model training. So that was something new for me, right? So I would say one thing to mention there is thank you so much, Abhishek, for this session. I would say I've learned a lot, and I'm sure everyone on here has learned a lot there. And again, thanks to all the participants for the great questions there. It's sort of nice to sort of see how everyone is following and sort of intentional about the questions they're asking as well. So one thing I want to mention or reiterate, like based off of our first one thing I want to reiterate, which I started with on the call, is so WaiTuTORIALs is part of the education part of the Women in AI program, right? So please, if anyone is interested in becoming, let's say, a speaker, if you have any session you would like to give here or any knowledge at all you'd like to share, so I've put a link in the chat there, right? You can go ahead and sign up, and we'll definitely look to send that in the emails as well. And then we also have this form as well for your feedback, if you, depending on how you found the session, or if there are things that you'd like to see next time. So we'll be looking to hear from you as well. And I think something to mention as well is that the next session will be on the 27th of July there. So if anyone is interested in just based off of what you've seen today, which I thought was an awesome session there, right? So it would be great if you could join as well. So we would have all the information posted on our LinkedIn page, and that session will be held by Madhuri Sawant, I believe. So keep your eyes peeled on our LinkedIn so you can have all of those details there as well. And then in August, we would have more of a wide practice session there. So it's more like a cohort base where you can learn in a group, and it basically puts you in a group of beginners, intermediate to advanced, depending on your level there as well. So also keep your eyes out on the page as well. So outside of that, I think thank you all so much for your time, unless anyone has any comments there. So if not, then I highly appreciate the time. And Abhishek, thanks again for the great session. So
Thank you, everyone. Thanks, Luciana. Thanks,
Abhishek.
All right, thank you.
Well done, Abhishek. Thanks, Luciana.
Thanks, bye.
Bye.
Bye. Thanks, everyone.
Thank you so much.